Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas? Why do some things glow in the dark? Why do animals not understand you? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Dave Ansell. First of all, please keep us up to date with the latest science news.
Well, something I thought was interesting this week is that Britain has now got a new land speed record.
Wow.
There's one that they've just broken the land speed record for steam-powered cars.
Right.
There's a team which has built a car called Inspiration. It's 7.6 metres long. It weighs 3 tonnes. It runs on LPG. It's got 12 boilers, heating steam up to 400 degrees C. It's got a steam turbine in the back. It sounds like a jet engine running. It's essentially a jet engine where it's making steam pushing through a jet engine, about 360 horsepower. And it got up to maximum speed 151 miles an hour. Average speed, both directions on the measured mile, of 148 miles an hour, which is quite impressive. What I think is actually more impressive, though, is that the record, which is just beaten, has stood since 1906, so over 100 years. And the previous car, which went 127 miles an hour, was a Stanley steamer. There was a guy called a nutter called Fred Marriott driving this thing. It's called the Stanley Rocket Racer. It basically looked like an inverted canoe. Did 127 miles an hour, not with the steam turbine, just with a normal backwards and forwards kind of conventional steam engine.
Fantastic.
And next year, in 1907, it probably did 150 miles an hour before hitting a bump and crashing and breaking to pieces. But it's incredible that it's one of these areas of science where no one hasn't done that much research on. Steam cars were like the height of technology in 1906. But after about 1920, internal combustion engines were just better, more efficient, easier, and no one really bothered researching them. So even now, with incredible amounts, they've used all sorts of computer designs and built this huge, great, really high-tech car. It only just beats a thing made in 1906.
That is fantastic. Good old Stanley the steamer, that's what I say. Brilliant, absolutely brilliant. All right, we've got lots of questions coming in. Let's press on with our questions right away, Dr. Dave, because we have quite a lot of them. Now then, question for Dr. Dave, says Mike. Domestic printers connected to computers, how do they differentiate between different colours? Dave?
Not quite sure what you mean by differentiate between different colours, Mike, but basically the way a colour printer works is the computer sends it code down the cable, especially with the modern USB cable. It's essentially a bit like Morse code down the cable. So there'll be different codes, which mean different colours. With big posh laser printers, it's not even just sending each pixel. They're sort of telling it to write a letter there or draw a line here and here, and then it builds up a picture in its memory, and then it prints it out. So basically, it builds up a sort of dot matrix, a matrix of pixels. So it's a bit like, if you imagine a piece of graph paper, it has a number associated with each square of the graph paper, which is the amount of different kinds of ink. So it would have probably cyan, yellow, and magenta ink. So kind of turquoise, yellow, and a sort of purple colour inks, and some black. It'll work out how much of each of those inks it needs for each square on the graph paper. Each of these squares on the graph paper are actually really, really small, far less than a millimetre, tenth of a millimetre, even smaller. It then, depending on the technology of the printer, inkjet printers will then squirt little blobs of ink, so it will squirt blobs of the different colours, the 4 different colours of ink on, and then if you look really, really close, you can see the little dots, and as you move further away, the dots will merge in to make a single colour. Laser printers do it with 3 different colours of toner. This is basically like powdered plastic. They charge up a roller. Then this powdered plastic will stick to the roller. In fact, they discharge the roller using lights, which is why it's sort of called a laser printer. It doesn't actually involve lasers. Discharges the roller, then different amounts of the toner will stick to the roller. It then gets transferred onto the paper. Then it has 3 or 4 different rollers for the 4 different colours of ink, and then it cooks it all to meld it all together. So basically it uses 4 different colours, and then those 4 different colours can be mixed together to make any colour, which you can see.
And they do it so quickly as well, don't they?
Incredibly. In fact, the really impressive thing is moving the paper around, in my idea.
Thank you, Mike, for your question. Now, John in Shenfield has sent an email in. He says, "Hi Sue, always lovely to hear you and hope you're well." I'm fabulous, thank you very much, John. Listening to Ian Puckey, who is standing in for Dave Monk this week, he was talking yesterday about wasps. Bzz. I had one in my camper the other night. I have a nest under my decking, which made the subject more interesting. My question is, if wasps only live for 1 year and only the queen survives, how the next year's wasps created? Good question, John. Dave.
Okay. I think the queens get impregnated in the previous year, and they store sperm over the winter in the same way that queen bees do. Queen bees only actually mate once in their whole lives, and they can live several years, and they just store up lots and lots of sperm, and they just mix it up with the eggs as they need them.
Really?
With queen bees, sort of when they go off, and then they mate with sometimes several drones, and then they go and land, and they build up their own colony. And then the queen bee builds her own nest and then raises the first brood of worker bees. And then slowly, as they get more and more worker wasps, so as you get more and more worker wasps, the worker wasps then start looking after the next generations during the summer. And then in the last couple of generations are then new queens and new drone wasps, which can then go off, will go off and mate, and then the queens go off and hibernate for the winter and start their own colonies the next year.
Fascinating stuff. Dr. Dave, says Dom in Chef Thetford, why is it when you add bicarb of soda to vinegar there is a reaction? What happens?
Okay, bicarbonate of soda is sodium hydrogen carbonate. If you dissolve that in water, you get little lumps called hydrogen carbonate, HCO3, which is negative, and then you get positive sodium ions floating around inside the water. When you add an acid, so vinegar or lemon juice or anything which tastes sour like that, basically what an acid means is you get positive hydrogen ions, so H plus ions. They tend to actually float around stuck to water, so you get H2O plus H plus gets H3O minus, H3O plus. So this hydrogen ion then meets up with the bicarbonate ion, the HCO3 minus, and then you get H2CO3. That can then break up into water and carbon dioxide, and the carbon dioxide can break off, form a gas, and will float off, form bubbles, and float off into the atmosphere. So you get that fun fizzing. Like you get in sherbet. Sherbet's got bicarbonate of soda and citric acid in it, and then can only react when they're wet. So when you put the two reactants in the sherbet on your mouth, they dissolve, react, and produce that exciting fizzing sensation.
Something tells me you like sherbet fountains.
I loved it when I was a kid. I loved making it.
Anyway, hi to Dave W, who sent an email in to say, why, when boiling water in a kettle, does the sound seem to go very quiet just before it reaches boiling temperature?
Very good question. Yeah, you've got a kettle there. It boils away. It slowly gets louder and louder and louder.
Yeah.
That's basically what's happening is you get bubbles of steam formed. Water boils, forms steam. Steam's a gas. When water boils, forms steam, it expands by 1,000 or 2,000 times. And so you get this bubble. And the water down near the element is really, really hot, so it's turning into steam. But higher up, the water's still quite cold because it's not near the element. So these bubbles of steam move upwards. And as they cool down again, all that water's shrinking by a factor of 1 or 2,000. All that steam is shrinking by a factor of 1 or 2,000, and these bubbles collapse. And essentially, you get these bubbles collapsing. And as they collapse, the water kind of accelerates as a bubble collapses and collapses and collapses until there's no bubble left anymore, and it sort of slaps against itself, and that forms a kind of cracking noise. Particularly small bubbles make lots and lots of noise, and it's actually called cavitation. This collapsing. As the kettle almost gets to boiling point, then the bubbles get bigger and bigger and bigger. And so instead of having lots and lots of small bubbles, each of which make one crack each, the bigger bubbles, you have fewer bigger bubbles, which got a lot more steam in them. But still, there's a lot fewer of the bubbles, because the small bubbles all join together to form bigger ones. That means there's a lot fewer bubbles which are collapsing as you get higher up, and also they collapse more slowly because the water's almost at 100 degrees centigrade, so they only collapse slowly as they go up. And once it actually boils, the bubbles don't collapse at all, they just get up to the top and pop and release the steam out the top of the kettle.
And that's why. Thank you, Dr. Dave. Now, hi to Matt, who says, what do scientists think our diet will be like in 100 years' time? What about me? Because that requires a lot of farmland, resources to produce, etc. In 100 years, what will we be scoffing, Dr. Dave?
My The simple answer is I don't really know. I don't know what the kind of general consensus is of scientists. I'm not sure there is one, really. Certainly, if we start running out of resources and if the population keeps growing, then there's going to be more pressure on food. And because meat uses hugely more, uses sort of maybe up to 10 times as much food. You've got to feed a cow 10 times as much food as you get out of it by eating the cow. And this means that meat is going to be a lot more expensive. So if food gets a bit more expensive, then meat's going to be very expensive. And so probably, certainly on average, as the whole world, we're going to end up on a more vegetarian diet. Doesn't mean you won't be eating meat, but possibly you'll be eating less meat, unless technology comes up with ways around it and ways of producing even more food.
Now, our next question comes from Giles in Hertfordshire. He says, the trick of getting a boiled egg into a bottle. How is that done, Dr. Dave? I've never seen one, have you?
I've done it a couple of times.
Have you?
One with limited success during a show, which was slightly embarrassing. But anyway,
Boom. Yeah,
not quite, more sort of flop.
Splat.
But anyway,
yeah, okay.
The first trick is you've got to peel the egg, which sounds a bit like cheating. But okay, you peeled the egg.
Yep.
And then you have a bottle with a hole in the top, which is a bit smaller than the egg.
Yeah.
You then need to somehow get this egg into the bottle. The trick is you want to reduce the pressure inside the bottle. So one way of doing it is if you light a match and drop the match in the bottle, that heats up the air in the bottle. The air expands. If you then, now the air's expanded, if you put the egg over the top, the match goes out, then the air inside the bottle is going to cool down and shrink. And so the pressure inside the bottle reduces. The air pressure on the outside of the bottle is still the same. So there's less air pushing up on the egg than's pushing down from the outside. So the air on the outside just pushes the egg into the bottle nice and gently. The real trick is how to get the egg out again. It doesn't work if you suck. But the trick is then if you hold the bottle up sort of up in the air, so the egg is sealing the case, and blow into the bottle, increases the pressure inside the bottle, and the egg gets pushed out.
If you're enjoying Ask the Naked Scientist, then you might like to check out The Naked Scientist, our regular roundup of the world's best science. Each week we take a look at the latest science news, talk to top researchers working at the coalface of discovery, and also get our hands dirty with a science experiment that you can join in with too. So make it a date and prepare to strip down science on the web at nakedscientist.com/podcast. Mike in Colchester has said, do airplane wings and helicopter blades work on the same principle?
Simple answer is yes. They both essentially work by deflecting air downwards. Aeroplane wing, on very simplest thing, if you get a piece of paper and drag it through the air at an angle, it hits air. If you imagine the air moving past it, the air hits the piece of paper, gets bent downwards. And if it also tends to stick to the top and get bent downwards on the top as well. This means that if the wing or the piece of paper is pushing air downwards, if you push something, it pushes you back. Isaac Newton worked this out. Every action has equal opposite reaction. So if the wing is pushing air downwards, then the wing is pushed upwards. A helicopter blade is basically a wing which is spinning. The problem with the wing is it can only push air downwards if it's moving. So planes don't work very well if they're stationary, they just fall out of the sky. So how do you make something which hovers? You have to make a wing which moves even if the plane's stationary. So the solution is you make the wing go round and round in circles on the top of a helicopter, which is fine. The only problem is if you try and make a helicopter go very, very fast, then if it's moving very quickly, then the blade which is moving forwards is going to be moving fast through the air, and it's faster than the plane's moving through the air. The blade moving backwards is going slower, so you get more lift on one side than the other side. So they have to have all sorts of complex mechanisms. So when the blade which is moving backwards has to be moving through the air at a bigger angle, so it gets extra lift than the blade moving forwards, which is moving at a very, very shallow angle. So that's what makes helicopters really... So you have to have a very complicated joint, which is carrying lots and lots of force and lots of torque. To attach the rotor blades on, which is why helicopters are very expensive and very difficult to make. And there's a limit to how big you can make them because you just can't make the mechanisms strong enough.
Now, Ian in Lowestoft has texted in and said, "Hi Sue and Dr. Dave. Why is it that I can sometimes pick up AM radio signals from Holland, etc.? However, the same never happens with FM transitions. Ian in Lowestoft.
Okay. AM radio waves are a much lower frequency. That means they've got a much longer wavelength. And this basically, if you've got light, all forms of radio waves are kind of light. And if you've got light, and if you shine, normally you think of light going just in dead straight line. So if you have an object blocking the way between you and the light, you get a really sharp shadow. But actually, if you look at it carefully, because light's a wave, you actually get light sort of bleeding around the edges of an object. So the edges of the shadow can get a bit of light in. So radio waves do the same thing. It's called diffraction. It will tend to bleed around the edges of a shadow. So even if you're over the curvature of the Earth. So the reason why we can't see something in Holland is because the Earth curves. So light going a straight line will never get around the corner. Now the light tends to only diffract a few wavelengths. So the longer the wavelength of light, the better it will diffract around corners. So if you use a very, very long wavelength like medium wave or even better long wave, then it will tend to diffract around the corner, and you can pick up signals from over the horizon. So you can pick up signals from all over hundreds of miles away. Whereas FM is a much shorter wavelength. The wavelength's a few meters, so it doesn't go around the corner nearly as well. So it doesn't diffract around the corner nearly as well. The only exception is shortwave, which has actually got a shorter wavelength than long wave, as the name suggests, but that can actually bounce off a layer in the atmosphere called the ionosphere, which is really high up above the stratosphere. And you can actually get reflections off the ionosphere, and that can go thousands and thousands of miles. It can actually reflect off the ionosphere and then off the ground again, and you can pick it up thousands and thousands of miles. So, yeah, normally the longer the wavelength, the further it'll go.
June in Braintree has called in. She says, I know tarantulas can bite, but can any of the larger household spiders bite as well? I've got a friendly one in my house at the moment. It was in the kitchen, and then I went up to the bathroom, and it got upstairs into the bathroom as well, so it must have gone up the stairs. I keep taking it out, but it keeps coming in. So can they bite, though?
All spiders can bite. Whether they can bite us is the question, because all spiders, all the spiders I know of, knowing biology, there's always an exception to any rule.
Yep.
But spiders make their living by eating. They're carnivorous. They eat other creatures, normally other small insects. Tarantulas, they can eat actually things like birds and small mammals. And the way they kill things is by injecting venom into them. Then they paralyse them or kill them, and they can inject things into the insects, which will slowly dissolve their insides, and then they suck the insides out.
Yeah,
lovely. So all spiders can bite. It's just whether they're big enough, whether their teeth are big enough and strong enough to puncture your skin. I think there are a couple of spiders in this country which can bite, but none of them which will do you much harm. Certainly nothing worse than really a mosquito bite or something. They'll hurt a bit, but not do you any harm. So, yes, other smaller spiders can bite, but in this country we're pretty safe thanks to our climate.
Here's one for you, and it's quite a long one from Tad. He says, a question for Dr. Dave, please. The birth of the universe was said to have happened with the Big Bang. A phenomenally small but dense sphere possibly exploded, and the universe began to expand outwards. To visualise this as a radio programme, we may think of it as a rocket we see on a bonfire night that produces an exploding chrysanthemum effect. Each component of the universe, gas, stars and galaxies, are all moving outwards from the point of the original explosion and away from each other. We can check this by measuring the light waves coming from the celestial bodies in the blue shift or red shift, and this tells us if an object is moving towards us or away from us. Far from moving away from us, however, scientists have discovered that the Andromeda Galaxy actually is on collision course with our own Milky Way. Any idea what might have caused this to alter course?
I think there's a few probably hundreds of millions of years before it could actually come anywhere. It's actually going to come anywhere close to us, if not billions of years. But yes, there's a general tendency for the further away you go, the further away things are, the more they're moving away from us. That doesn't mean that everything everywhere is moving away from us. because just in general, some things are moving. If nothing was moving away from us, some things are moving towards us, and some things are moving away from us. I mean, yeah, you walk around outside, and some people walk towards you, some people move away. If you look out inside our own galaxy, some stars moving towards us, some stars moving away from us. So for a start, the motions are all pretty random. And then you add on top of this a tendency for, on average, things to be moving away from us. And so that means that, especially when things are quite close to us, the Andromeda Galaxy, by the standards of the universe, it's the closest major galaxy to us. By those standards, it's quite close. So if it just happens to be randomly moving towards us, and then the tendency for things to be moving away from us isn't going to be overcome, so it can still be moving towards us. There are other galaxies further away which are moving towards us, but the further away you look, the rarer they become, because the further away you look, the bigger the tendency for things to be moving away from us. So basically, it's quite close to us, and randomly some things are coming towards us and some things are going away.
OK, well, more texts and emails coming in as well. Who have we got now? Derek in Wellingborough says, if we evolved from apes, then why genetically do we still have the primitive form? And what initiated this differential genetically somewhere down the line? Why have not other species, like crocodiles, etc., developed also? Many thanks from Derek. Oh, it's a tricky one, Dave.
That is it's actually quite a deep question. I think it's sort of to do with what evolution is. I think looking at ourselves, we obviously think that we're the pinnacle of evolution, but we're not. Evolution doesn't have any direction. All it does is at any particular generation, all it says is that any particular generation, the creatures which are best at surviving will survive. And because we've got inheritance, we inherit our parents' DNA, that means the next generation will probably be better at surviving than the last generation. Mm-hmm. So slowly things get better and better adapted to a certain set of circumstances. And we have common ancestors with crocodiles hundreds of millions of years ago. And if you have a population, part of the population happened to be in an environment where it was better to survive by being in one way, and another part of the population found it better at surviving by being in another way. Why are we the only creatures which seem to have developed sentient, be able to know what we are, be able to build things? I guess because it's actually very difficult to evolve our level of intelligence with the ability to build things. Every stage has got to be better at surviving the last stage, and I think the only way that humans have evolved is through a particularly fortuitous set of environments and climate change over millions and millions of years, and you happen to have got in every generation it's been better to get more like a human. And then all of a sudden, for a long time, humans were incredibly unsuccessful. They think our population went down only to about a couple of thousand at some point, maybe a million years ago, or even less than that. And it just so happens that this incredibly unsuccessful ape, which seemed to be putting all of its effort into creating these big brains, and normally a big brain's a really bad idea. Big brains use a huge amount of energy. They use about a third of our energy, and we're sitting around not doing anything. For any creature, that's a really bad idea, because you're burning all this energy which you could be using for reproducing and having more children. But it just happens that through probably some weird sexual selection thing at some point, apes found other apes who were intelligent more attractive than thicker other apes. So slowly they evolved, probably through sexual selection, all sorts of other things, to get more and more intelligent. And then we discovered, and that happened to have the side effect of being able to use tools and be able to build big, complicated societies. And all of a sudden, a few tens of thousands of years ago, we suddenly took off and became incredibly successful. So, yeah, it's just there haven't been all the intermediate steps for a crocodile to become intelligent and being able to make space rockets.
Right, a couple of questions here. Malk made an observation. He said, radio waves, they can, on odd occasions, play extremely odd tricks. I once heard Land's End Marine Radio on 500 kcs when we were off the Indian coast.
Yeah, it's probably the ionosphere playing tricks. Sometimes it can, especially if you get solar wind bumping into it, lots of charged particles flying off the sun, they can distort it and do all sorts of strange things, and sometimes you get radio bounce in all sorts of strange direction. Right,
here we go. Hi, Susie Yuki. Hi, Doc, says Nigel in William Park, Milton Keynes. I'm back online at last. Blooming technology. This is a daft question. Don't we all just love all this evolution stuff? Humans have only been sapient for a very short time and yet made huge advances. Other species don't appear to show any sign on the huge changes we made, despite almost being unchanged for millennia.
As in, other species haven't been changed by all of the changes we've made. There certainly have been some species which have changed. There's a fairly classic case of butterflies, which, as the environment got sootier during the 19th century, slowly went from being mostly white to being mostly black. Certainly, when we've had a direct effect on species, they've had really radical changes, like dogs. In fact, dogs. I mean, if we didn't all call them dogs, if you came here from another planet, you'd think there were lots of different species.
Yeah,
because you would never think a Great Dane was at all related to a little tiny Pekingese or something.
That's true.
Yep. I mean, we are certainly having effects, and we've bred all sorts of new features into bacteria by attempting to kill them with antibiotics. The antibiotic resistance is coming along. And the other thing is that recently fish seem to eat fish in where they've been heavily fished. Because there are lots of rules that you can only take fish which are bigger than a certain size. Various fish populations in the sea are evolving smaller. Because the fish which don't mature, if you're only allowed to take fish which are more than a foot long, if you're a fish which matures at 11.5 inches long, then you don't get caught by the fishermen. So animals are evolving from our effects, and lots of behavioural effects as well.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.